Okay, and this is today's training session. So I will introduce the 3D printing and laser engraving, the writing and drawing, and the conveyor belt kit, and the sliding wheel kit, and the vision kit. Okay, so at first, I will introduce the 3D printing. Okay, and this is a video about the 3D printing instruction, how to prepare materials, install and use software, and etc. But this software or this video is an old version named the Doodle Studio. So now the Doodle version has multiple functions that can be realized through the Doodle Lab. So I recommend you to use Doodle Lab. So in today's training lesson, we combine the functions of Doodle Studio and the Doodle Block into the Doodle Lab. So I just only introduce the Doodle Lab software in this PowerPoint and in the demo video later. So I will skip this video, but you can watch it by yourself after the training session. Okay, so next, I will continue to introduce more details about 3D printing. So first, here are some materials you need to prepare before start the 3D printing. So we can know the materials. This is the Hodent, and this is the PTFE tube, and this is the extruder and motor cable and filament, and this is a filament holder. Okay, and the 3D printing process is shown in this picture. So when we start, we need to install a 3D printing kit, and then to bar the firmware, and then to start the 3D printing and end. So next, I will introduce how to install a 3D printing kit. So we can know from this page, step 1, we need to press down the lever on the extruder and then to push down the filament to the bottom of the via the pulley, and then to collect the end of the PTFE tube to the Hodent and push it down to the bottom of the Hodent, and then to collect the other end to the extruder. Okay, and step 3 is to insert the filament into the PTFE tube and put it down to the bottom of the Hodent. So we can know this the white cable, it's a PTFE tube, and this one is a Hodent. And then to fix the Hodent on the magician with clamp the fixing screw, and then to insert the heading cable to the interface, the 4, and on arm, and then the fine cable to the interface 5, and the thermistor cable to the interface 6. Okay, and step 6 is to connect the extruder to the step 1 interface on the back of the base with the motor cable, and then to place the filament and the extruder to the filament holder. So we can know this is a filament holder and this is the extruder. Okay, so next I will show you how to operate the software. Okay, and this is the main page of Doodle Lab. So in this page, users need to click the 3D printing lab. So when the user enters the 3D printing lab, they will show the following pop-up windows. So here are two suggestions. So if you haven't yet bought the 3D printing firmware, you need to click the Onboard, and then to select the device and port on the firmware upgrade page, and then to click Collect, After the selecting the firmware type, to click the start to upgrade. But if the 3D print the firmware has been burnt, you can directly open the 3D printing software to use it. Okay, and on the other hand, you need to open the repeater host and set printing parameters and the printing parameters just needed to be set for the first time. So we can and then to click the printing settings in this page on this icon. So you can set the parameters in the following red box, and another parameters are set by default. So when you finishing the settings of the parameters, you need to click apply and to turn to the printer. Okay, and on this page, you need to select the options which are the disable motor after job working and the go to park position after job working, and this one, the printing has SD card. So and another venues are set by default, so you don't need to change it. So then to apply and go to the next page. So this is the extruder tab. And in this page, you just need to set the diameter and then to click apply. Okay, and this is the printer shift page. So you can set the printer type, so X, Y, Z axis, and print radius and the height. So when you finish setting the all parameters, you need to click apply and OK. So after the setting the parameters, let's go back to the repeater host page. So in this page, you need to collect the repeater host page to the magician by click this button. And after the selection is successful, the current, the heating temperature will be shown in these pictures. So before the printing, the users need to test the extruder to check whether the melted filament flows from the nozzle of the extruder. And the temperature of the extruder will be about 117 degrees Celsius. So the Doodle machine will not start the 3D printing until the filament is in the melted state. So you need to heat the extruder first. So next I will introduce how to heat the extruder. So the step 1 is to set the temperature to the 200 degrees Celsius on the manual control lab, and then to click this icon to start heat. And then step 2 is to click the extruder feeder when the heating temperature is up to 200 degrees, and then to feed up to the 10 millimeters to 30 millimeters. So if your melted filament flows from the nozzle of the extruder is working properly. Okay, and next, you need to adjust the printing space and get the printing coordinate. So here are two ways to get the printing and coordinates. So the first one is to press the unlock key on the phone arm and to drag the robot to make the printing head contact the surface of the masking paper, and then to release the unlock key. And then we can need to input the command named the M415 on the G code. command window and to press enter to get the current coordinates. So, and in other one, you can also press the key button on the back of the base to get the current coordinate. But if you can find the Gcode command, please check this the green one into the easy to close the easy mode. So the easy changes from the green to red, indicating success closure. Okay, and then we need to note to import the prepare the 3D printing model you saved in your local file like this picture. Okay, and then after importing the model, you can change the size of the model. So, for example, you can center or zoom or rotate the models on the object placed placement page. Okay, and then we need to set the slicing parameters and the slice style. So we can click the features, the configuration to set the slice 3R from slicer on this page. So when we enter the configuration, we can see this page. So we can see some of the parameters about the slice, and then to select the slicing parameters on this page. Okay, and then to save them, to save the printing settings and the film settings and the printer settings, and then to save them. Okay, after the saving the parameters, just to click the slice with the 3R on this page to complete the slicing. Okay, and then to click this icon on the repeat host and on the repeat year host page to start to print. Okay, and next I will show you a real demo about the 3D printing. So just hold a moment. Okay, now share a screen about a video, the 3D printing. So we can know here are some materials for the 3D printing kit. So okay, so at first, when we start to prepare the materials, we need to pull down the filament to the bottom of the hole via the pulley. Okay, and then to collect the PDF tube to the quadrant and push it down to the bottom of the quadrant. Okay, and to collect the other end to the extruder. Okay, and then to fix the quadrant and the position with the clamp, the fitting screw. Okay, then to insert the cable to the interface and the robot forearm. Okay, then to place the extruder on the filament, the holder. Okay, but before that, we need to assemble the filament holder like this. Okay, and then we need to connect the extruder to the robot, the stepper 1 interface on the base of the robot. Okay, then to connect the USB to the computer and to connect the adapter of the machine. Okay, and then we need to stick the tabs on the glass. Yeah, like this movement. So yeah, because we need to put the 3D printing the model on this glass. Okay, the installation got ready, so we are about to operate the software. So the first, because we haven't bought the 3D printing firmware, so we need to click the node and to start to upgrade the firmware. So sometimes the firmware upgrading will take a few minutes, so just to wait. Okay, so then we are going to go the repeat the host to set the parameters on the printing setting. So we need to set some pointers, for example, the port to the COM1 and the baud rate to this value. And another one is the reset on the collect and the emergency words on the save cache size. So you can refer to these parameters according to the user guide, and then to click the apply and then to enter the printing. So in this printing, the setting page, we just to select the 3 options and then to go to extruder. So in this extruder page, we need to set the diameter. But in this page, we tend to set the home X, 1X, XYZ axis. Okay. And some printing the ratios. Okay, to click apply. Okay, and then to collect the margin to this software, but sometimes like this error will occur. Hold on, please. Okay, in this case, we should open the repeat the printer settings and go to the collection settings once again and to change it to the machine port. Okay, to collect it once again. Okay, next we are going to set the temperature. So we need to set the temperature is up to 200 degrees. And to click this icon. So when the temperature is up to 200 degrees, we can to set the repeater. So we can know the temperature is very mild by seeing this area. Okay, now the temperature is up to 200 degrees. So next we are about to click the feeder and let the melted filament flows from the nozzle of the extruder. So we can know from this video, in this case, it shows the extruder is working properly. Okay, next, we are about to get the coordinates. Yes, so we just need to input the command, the M415 and the G code to save this coordinate. Okay, then we're about to import the 3D printing the model you saved in your local file. Okay, when we open the model, we can to exchange the size. For example, to center or to those by click on the icon. Okay, and next we are going to click the configuration, this one, to set the parameters on the slide 3R, the second page. Okay, so here are some the attachments named the Dubot to zero Vita and the Dubot to Z and the Dubot to 2.0 Vita Cuna were on this one. But I want to know about the Dubot. The 2.0 Visa is used for the printing of thin letters the base, and while the Dubot 2.0 and to save it. Okay, so we set the Dubot the 2.0 and in each the creative settings and filament settings and printing settings. Yeah, because today I select filling the model, so I choose the Dubot 2.0. Okay, and then to save them. So next we will start to print the 3D model. Okay, so we can know from the script. So the machine started to move and to work. So like this one, the machine started to work on the started to print the 3D model on this paper. Okay, we can get the image on the Wikipedia host to know the real time about this the printing the model. Okay, thank you very much. 请想 Okay, and thank you for your watching. And I finished the introduction about the 3D printing. So from now we are going to take a break for the 10 minutes. But I very sorry to say that I will appreciate if you can take a few minutes to fill out this enquete. Okay, so it's just needed to write your name and your company and your country. Okay, so we will restart in the 10 minutes. In the 10 minutes. 10 minutes. Okay, hello everyone, welcome back. So on this 3D printing, this I will share some frequently asked questions with you when you are operating the 3D printing. Okay, so at first, it's question 1. Why the indicator light is yellow when the machine is 3D printing? So because the 3D printing kit is not properly installed, so you need to collect the keyboard correctly. And then it's number 2 question. When the machine is correct, but why can't move it when clicking on the XYZ axis? So in this case, please try the following steps to do it. So number 1 is to confirm the printer settings as shown in these pictures, and then to press the reset button and recollect the machine. And number 3 step is to reset the M415 or the press key to get coordinates. And next, you can try to repair the 3D printing firmware. Okay, and then the question 3. What to do when the printed object is inclined? So in this case, please reach the machine firmware and calibrate it before trying the 3D printing again. Okay, and the next question is if the filament doesn't work properly in the hotbed, so what can be done in this case? So I recommend you to try the following steps to do it. So the first one, if the distance is too big, then the filament will not stick to the bed properly, and if it's too small, then it will clog the nozzle. So, and then you can check whether there is no filament come out from the nozzle. So please heat the extruder to the 200 degrees Celsius and to push down the lever. So use your hand to push the filament into the extruder. If the filament comes out from the nozzle freely, then the nozzle is not clogged. So, and number 3, you can check if there is still no filament that comes from the nozzle when you need to hit a hot end and pull down the filament, and then to cut off the melted part and reload again to see if it's work or not work. And next, if all the methods still not working, then you need to disassemble the hot end and part by part to clear up the clogged the nozzle is long needles or another tools. Okay. Okay, and next I will introduce about the laser engraving. So I will skip this video as well. So at first, to operate the laser engraving, you just need to laser kit. So this is the laser kit process figure. So when we start, we need to install a laser kit and then to collect to the dot lab and then to import a picture and then to set the engraving the parameters and then to adjust the laser focus and start to engrave. So next, I will introduce how to install a laser engraving kit. So we can know from this picture. So step 1 is to fasten the laser kit to the end of the duct machine with a clamp fixing screw. And step 2 is to connect the power cable of the laser to the SW4 connector on the forearm, and then the TTL control cable to the GP5 the connector. Okay, and the next to place a piece of the brown paper on the work face within the workspace of the Dupont magician. Okay, next I will show you how to operate the software. So this is the main page of our Dupont lab. So users can click the laser engraving lab. So when we enter this lab, users can click the drop-down lift or the device collection panel to collect the machine with the software. Okay, and then to click the open to import image or the pictures from a local file you save in your computer. Okay, and then you can drag the picture to change the size, the position, and you can also rotate the angle or flip the mode of this picture. Okay, so the picture in the drawing area should be placed within this area. So if not, the robotic arm reaches its limited position and can't engrave. So the image will show the highlighted with a red border like this picture. Okay, and then to click the home in this panel to let the robot to go home in position, and then to select the laser as the end effector in this control panel, and then to click the open after the engraving it. So the laser kit will emit the laser. You can adjust the laser power range. Okay, so adjust the laser focus length place and hold the unlock button on the forearm to move the robotic arm to rise or lower the height of the laser. Still, the laser is brightest with the smallest possible spore size, like this picture. And then to click this Alt Z to obtain and save the current value of the coordinates, and then to click the synchronize to move the laser kit over the starting point of the engraving. Okay, and next, just to click the run button to let the machine start to engrave. So now we can see in the screen the cursor shows the position of the laser in the real time. So the running process can be displayed below the engraving area. So in this is the running area. So you can click the pause or to click the stop to operate the process of engraving. Okay, next I will show you a demo about laser engraving. Okay, to operate the laser engraving, we just need a laser kit and a tape and a goggles and a brown paper. So first, to fasten the laser kit to the end of the Dupont magician. And then to connect the laser kit to the laser cable to the robot. Okay, then the users must wear the goggles to protect our eyes, and then to stick the tape to the brown paper to facet. You like this one? Okay, next we are about to go to operate the software. Okay, so this is the main page of the .lab. So we may open the .lab and enter the laser engraving lab to collect the margin with the software and then to import pictures. Okay, to click the open to import the pictures and then to change the size of this picture. And to make it center in this area. Okay, and then to click the home button, make the robot arm move to the zero position. Okay, we can know from this video, the robot arm started to move to the zero position. Okay, then to select the laser as an effector, and then to turn on the laser. Okay, so now the laser kit will emit the laser. Users can adjust the laser power range and focus the lens, like this one. So we can adjust the laser engraving, the speed. Okay, and then to click the run to start the laser engraving. So we can see the running process in this area. Okay, thank you for your watching. Okay, so next I will share some frequently asked questions with you. Okay, so number one question. So if the laser modules can not burn the papers at first time, so what can be done? So in this case, please try the following steps to operate the laser engraving. So at first, to check whether the collection of laser is right, and then to check whether the laser can be focused. So if the laser is always unable to focus, it may be the focus length of laser is too long. So you can try to focus by turning the knob on the bottom of laser, and in this one to turn this button, and then to change and to adjust. And then number three, you can try to check whether within the materials of laser has a high reflectivity. So please change a brown paper to check the problem. And next, if all the number 3 to 1 ways are failed, the laser may be malfunction. So in this case, please change another laser to test. Okay, and next I will share with you how to operate the writing and the drawing. Okay, I will skip this video as well. Can directly enter about the writing and drawing. So to operate the writing and drawing, you just need to a pen and a pen holder. So this is the writing and the drawing process in this picture. So when we start, we need to install our writing kit and then to collect the conversion to the dot lab and then to import a picture or the image and set the writing parameters and next to adjust the position of the pen nib and start to write. Okay, next I will show you how to install the writing and drawing kit. Okay, so step 1, you need to place a pen in the pen holder. Okay, and then to fasten the writing and drawing kit to the end of the dot machine with a clamp fixing screw. Okay, and the next is the step 3. Step 3 is to place a sheet of the paper on the work surface within the workspace of the dot machine. Okay, so next is how to operate writing and drawing software. So when we open the dot lab, we can click the writing and drawing the modules. And then to click the collect to let the machine connect with the software. Okay, so before the machine starts to write and draw, you need to import a picture from the local file or to type the text in this typing area. And then to click the add. So the picture appears in the drawing area like this. So as an example, we type the duplicate. So we can see it, the duplicate in this area. Okay, and then if you need to insert a picture, you just need to click the open to select a picture from local file you saved. So if the image format is not SVG and the SVG format conversion pop-up will pop up. So in this case, you need to select the conversion scale and click OK. So we can drag the picture to this area and to change the size of this picture. Okay, and then to click the settings to set the pen lip, the lifting height and the descent height and the speed. So generally, the pen lifting height and descent height are set by 20 default. Okay, and next, the users just needed to click the home and then to select the pen and as an effector in the ARM control panel. Okay, next, we need to adjust the margin position and get the current Z coordinate. So please to press and hold the unlock button on the forearm to move the margin to near the pen nib until it squeezes paper. And you can also jog margin in the arm control to pull the coordinates down the suitable position for the writing, and then to click the auto thing to open and save the current menu of the axis, and then to click the synchronize the icon to move the nib over the starting point of the drawing. Okay, and to click the run, I'm going to start to draw the picture. So we can see the running process in this area, and you can also to control and to click the pause or the stop to pause or stop the drawing. Okay, and you can also click the download this icon to download the file to the device. Okay, next I will show you the demo about the writing and drawing. Okay, I shared my screen about this video. So this video is about the drawing and the drawing. So we just need a pen holder and a tape to do it. So at first, we need to fasten the pen holder to the end of the double machine. So it's very simple. Okay, and then to stick the tape to the white paper to fasten it. Okay, and then we need to open the duplex. Okay, and enter the writing and drawing in this module to enter this page. Okay, and first we need to collect the margin. And by default that we need to choose the money firmware as the firmware type to update. Okay, next we are going to back this page and then to enter the text in the rectangle box. Okay, in this area. Okay, for example, we type the DoBot. So when we click the Add the DoBot, video appears in this area. So we can change the size of the DoBot. And then to click the arm control. And then to setting the pen lifting height and descending height. Okay, now we are going back. Okay, so now we are going to about to get the z coordinates and save the axis values. So we can press and hold unlock buttons or on to move the robot to lower the pen nib until it slightly screws the paper. Okay, and then to click the synchronize and what Z to get the Z coordinates and save the Z axis value. So if we click the run, the robot will start to work and to write the image on this area. So we can see the run process in this area. Okay, thank you for your watching. Okay, next I will share with you about when you are operating the writing and drawing. So here are some of the frequently asked questions. So question 1, when the writing and drawing while the writing process is stuck or the pen keeps not moving. So in this case, it may be caused by too much noise in the conversion. So you can slightly reduce the conversion ratios like this one to change this venue from the big venue to a smaller venue. Okay, and this is number 2 question. So why the image is highlighted with a red border like this one? So in this case, the picture in this area should be placed within the avenue area. So if not, the robot arm reaches its limited position and can move or join. Okay, so the above contents is an introduction about the writing and the drawing. So from now, if you have any questions, you can ask us online or send the questions to the Zoom chat box. So have any questions? Okay, if here are no questions anymore, we are about to take a break for 10 minutes. So during the break time, if you haven't finished the untick, so I hope you can take a few minutes to fill out it. Thank you very much.
Conexão. O que é isso aqui? Ah,
Okay, hello everyone, welcome to back. So next we are going to restart the training and continue to talk about the conveyor belt kit. Okay, so at first, I will introduce some of the materials of the conveyor kit. So it includes photoelectrical sensors and the mini conveyor belt and some the assembly, the introductions and the photoelectrical switch and the toolkit. Okay, and here is the specification of the conveyor belt. So we can know some of the parameters such as the payload and the maximum speed and the net weight and some other parameters. Okay, and this is the specification about distance, the measure, the sensor unit, and the camera recognition, the sensor unit. So we can know some of the, for example, the input, the voltage is 3 to the 5 voltage, and some other parameters. Okay, so next I will show you how to install the conveyor belt kit. Okay, and in this part, if you want to use the 2 robot arms to operate conveyor belt kit, please follow the instructions in the pictures below. Okay, but in today's training, we just only use the 1 robot arm. So regarding the collection, please collect the motor cable of the conveyor belt to the step 1 interface, and then to collect the counter sensor cable to the robot, the GP2 interface, and then to collect the photoelectrical sensor to the robot arm GP4 interface. And okay, so the collection method shown in this picture. Okay, and the following features give some instructions for use the camera sensor and the photoelectrical sensors. So I want to some of the difference between the different vibrations. So this is the camera recognition, the sensor instructions. So in these instructions, we need to use a camera recognition the sensor block, press in the block link and the module to get the camera state. And then you can search the I/O the port to get some camera information like this one. Okay, and this is about the photoelectrical switch instructions. Okay, so next I will show you how to operate the duplex and make the conveyor to move and to transport the object to another location. Okay, and when we open the duplex, you need to add the conveyor, the kit extension, and the dot block lab interface, and then to write the program form in the code area. Okay, to write some the following sample the program, then we can set the parameters in each function, such as the convert the motor, speed, and some to set the status of the inflated sensor. Okay, and then to run this the program, the machine and the conveyor belt work together to transport the different counter objects from the one location to another one location. Okay, so next I will show you a real demo about conveyor belt kit. Okay, so now I shared a screen about this, the video, the conveyor, the kit for this training. So we can see some of the ConvertKit accessories on this table. So at first, we need to fasten it. Okay. Okay, first to fasten the photoelectric sensor. So this is the photoelectric sensor. So we need to fasten this to the robot arm. Okay, and this is the camera sensor. So to fasten the camera sensor to the conveyor. Okay, then to place the suction cup to the machine's forearm and connect the cable to the robot and the conveyor belt. Okay, this is to connect the cable from the conveyor kit with the robot. Okay, and this is the USB cable. So we connect the USB cable with the computer. And then to fasten the air pump box to the machine. Okay, and to connect the pump box cable to the machine's forearm. Okay, and insert the power adapter into the power cable, and then to connect the electric source and the power to the robot. Okay, next we're going to enter the dot block lab. Okay, at first we need to collect to collect the machine with the port combine. Okay, and then to add the extension as a photo, electrical, and the camera sensor. Okay, so we can write some program in the code area. So at first, we need to set start the command. So when we to enter the space, the key, so the program will start to run. Okay, and then to set the margins, the motion ratios, the velocity, and the jump height. Okay, and then to set the sensor, the infrared sensors, and the camera sensor status and the version. Okay, and this is about the set the conveyor to motor stepper. So stepper is the stepper 1. Okay, and second, we need to repeat the forever loop function. So this is about the loop function. So we need to wait the 1 second. So then the if function, if condition function, we will set the if condition which gives the inference sensor stable and conveyor motor stable. Okay, so I'm going to say some of the consequence functions. So here are from the set conveyor motor to this, here are all the consequence functions. So the if condition function just this to if get the GP1, if this common equals GP1, so the program will the robot will run from say the conveyor motor step 1. So in this, the consequence functions we need to set the jump motion and manage the suction cup arm. So and this is the if else the condition function. So when we type the structure of this the program, we need to set some of the parameters, the value. So here's some of the values about the height value and the port count, and some x, y, z are the axis, and then about the wait time and the speed. Okay, so and this video, this is the video about the merging and the conveyor belt work together to transport the object of the different corners from one location to another location. Okay, thank you very much. Okay, so next I will share some review about the FAQs. So first, question 1, how to know the version of the photoelectric sensor and the camera sensor? So here, this is the lab on the sensor with the version white on it as shown in this picture. So we can know the version is 2 and the series number is this. Okay, and the number 2, what's the mode of the camera sensor used in the conveyor kit? So the camera sensor mode is TCS3200. So the relative information is shown in the following pictures. You can refer to. Okay, and this is question 3. When the object is in front of the photoelectric sensor, but the photoelectric sensor can't detect the object. So in this case, how to solve it? So you can use rotate the button on the back of the photo sensors to adjust its sensor distance. So in this one, to rotate this button. And the clockwise means to make the distance longer, and the counterclockwise means to shorten the distance. Okay, this is the question 4. So the conveyor belt, the camera sensor doesn't work properly. So what are the possible reasons? So for this reason, you can try to analyze the following reasons and try the following steps. So number 1 is to check whether the current software firmware and the software versions support the camera sensor. Okay, and next is number 2 is to check the distance between the camera sensor and the object should not be too long or be too short, within the range of 5 to 10 millimeters. And then next to check whether the camera sensor interface is constant with the actual interface. Okay, so this is about the conveyor belt kit instructions. So for this part, if you have any questions, please talk with us freely online or to send the questions to the Zoom chat box. Okay, if no questions, I'm going to about the next part. So this part is the sliding rail kit. So at first, I will show some of the materials about the sliding rail kit. Here are the sliding rail and the tool cage and the wire seat and the attachments and some assembling instructions. Okay, and here is show a specification about the sliding rail kit. So we can know from these specifications, for example, payload is 5 kilograms and effect travel distance is 1000 millimeters, or some the maximum speed and maximum acceleration, and about some the distancings or this sliding rail kit's the weight. Okay, next I will show you how to install a sliding rail kit. So at first, the users need to mount the robot A with the plate of A, and then to fix the plan A with the plan B with the 3 screws. Okay, and then to fix the holders of the cable to the plan A, and then to connect the cable to the holder, like this, in these pictures. So, and then to connect the cable to the robot. So, in this case, I hope you can note if the additional earphone box is to be used for the handy applications, so the plan C can be used. So in this case, to use the 2 screws to plate the C to plate A from the bottom, and then to fix the arm pump box to the plate C. Okay, next I will show you some operations of this software. So you need to, but at first, when we enter this dot block lab, you need to Add the sliding wheel kit extension on the DoofBlock Lab interface and to write a program in the code area. So the process of writing a program, you can view the help document such as the DoofLab, the program manual. So you can refer to this when you are typing a program. Okay, so this is an example program to make the machine moves on a slide to move a small object from one location to another one. So when we type the program, we need to see some parameters. For example, the speed, or to say some the sensor motors, or another the point, the coordinate. Okay, so I will show you them about the sliding wheel kit. Okay, so in this video, here are some of the sliding wheel kit materials. So it's the machine, and it's the plant A and B, and it's the air pumps. Okay, and this is a gripper. Okay, so at first, we need to mount the robot with the plant A, B. So, and then to fasten the machine to the slide wheel. Okay, so next we're about to fix the gripper to the robot forearm. And this is the electrical gripper. And then to connect the cable to the robot, the interface. Okay, and then to connect the wheel kit, the cable to the machine, the interface. Okay, and then to connect to the air pump box cable to the gripper and facing the pump box to the machine. And connect this the air pump, the cable to the machine's forearm. And place the air pump on the plant A. And then to connect the cables with this to the machine's base. Okay, next we are about to connect the power electric source and the USB to the machine. So this is the adapter, the machine adapter. Okay, and this is the USB. Okay, then to power on the robot. So we can see the light indicator is the green. Okay, so next is the software operation. So enter the duped block lab and collect the merge sheet. Okay, and then to add the sliding the rookie extension. So in this, the training we will upload from the local file I saved. So and then we can now list the program port. Okay, and then to collect the merge and to check this the real. So we can check whether the sliding rail is working probably by selecting the real rail and the check the L, the minus or the L plus bottom. So we can now from this video the robot start to move, which means the sliding rail kit is working properly. And this video it shows merging moves a small object from one location to another one. Okay, thank you for watching. Okay, next, I will share with you some of the questions. So, number one, so the zero return the position of sliding rail is unblockable. So, how to make it move to the zero position? So, in this case, after the performing the zero return operation, if the sliding rail is in an abnormal zero return position, you can control its the movement through the L minus or the L plus button on the dot block, the lab interface to move it to the zero position. And then about the during during the use of the sliding rail, if there is an agglomerator to zero, which directions can be generally used for the troubleshooting? So at first, we need to check the wire collection is correct or not. So I mean, the motor wire must be correct to the stepper 2 interface and the motor wire interface and the Merrick switch interface is already loose. So next is to check whether the 10-pin communication interface is malfunction. So if it's, the merging should be returned to the factory and repaired. So this time you can contact us into the support email. So so this is about the sliding rail kit introduction. So if you have any questions, you can talk with us. If you don't have any questions, I will go to the next part. Okay, the next part is about the vision case. So vision case is the most difficult part in today's training sessions. So first, I will introduce some of the vision case materials. So this is the vision kit, the shipping list. So when you order the vision kit, you will receive those materials. So for example, the industrial, the camera lens, and the industrial, the camera, or the USB dongle. And then you can receive the camera, the mounting kit. So in mounting kit, it includes the camera support and camera mounting plate, or some of the washers. And then this attachments. So in attachments, here are some of the demo supplies or the blocks. And this is extension the full kit and the camera light kit and two package and the camera plate. So, but if you ordered the Duke M1, not Martian, you can also receive the camera plant just only works with the Duke M1. Okay, and this is the specification of the HD Corner industrial camera. So please note, I want you to know some of the parameters from these specifications. For example, the sensor size or the sensor model and the effective the pixel. But I want you to know the effective the pixel is 5 millimeters, and this means the number of the pixels involved in the camera's light, the sensitive the image, and so you can know some another details from these specifications. Okay, and this is the white light source specifications. So we can know some for example, the output voltage is 10 voltage and the watt power is 3.5 watts to the 5 watts. And some the real the diameter, the inside max is 39 the millimeters, or we can know some the weight or the working environment. The temperature is from the 0 degrees Celsius to 14 degrees Celsius. Okay, and this is the 6 megapixel 12 millimeters fixed the focus length specifications. So we can know some control mode and some of the field, the angle. So we can know the angle if it's the angle D. The angle is 41.2 degree, and the angle H is 34.4 degree. And some the blank, the focus length is 17.526 millimeters. Okay, and another amount or the feature. Okay, and next I will show you how to install a vision kit. Okay, so to install the vision kit, at first we need to fix the flange support of the extension port to the bottom, and then to fix the extension port to the camera plant, and then to assemble the camera support 1, 2, and the camera support 2, and to mount the camera support 1 on extension port and not under the next is step 5. Step 5 is to fix the camera to the camera and the mounting plate, and the step 6 is this. Step 6 is to fix the camera mounting plate to the camera support 2, and the last step is to mount the light source and the camera. Okay, so assemble the vision kit, then to connect the light source to the machine. So to get more details, we need to first to collect the merging the light source switch to the power cable or to the power adapter of this robot, and then to collect the light source switch to the power interface of the dual merging, and then to collect the light source collect the merging light source switch in this cable to the light source cable. Okay, and next, to fix the machine to the platform. So this is the platform, and then to adjust the camera support to make sure the camera can view the work face of the machine. Okay, so this is about the software operation. So this the Doobot the Vision Studio software integrates various algorithms contents of the machine, the vision. So it's very suitable for a variety of application scenarios. So through the Doobot Vision Studio software, the user can detect the distance and detect the metal and the medicine or the bottle, and or to measure the diameter or to match the rectangle and the circles. Okay, and this is a main page about the Doobot Vision Studio. So here are the 4 modules can be chosen. So first is the general solution, and next is the location measures and the defections, and the recognitions. So in this general solution includes the 3 later the modules. So you can choose a module according to the ad type, or you can open the recent the solutions you create in the Doobot Vision Studio before. So, and when we enter the general solutions, we can see this page. So in this page, we can know the first is the area 1. This area is the menu bar. So in this menu bar, it includes the files and settings, system, the tools, or the help. So you can to view some of the help documents, to click this help button, and then this is the control the toolbar. So it provides the quick operations for the software, including the file saving and file open, or the camera management and the controller management, and etc. Okay, and next is about the toolbar, area 3. So in the toolbox, it includes image collection and measurements and calibration, or to precision and the image processing and the color processing, and another communications. Okay, and next is about this is the flow process. So you can create or to edit the flow in here. And this is area 5. Area 5 is the image area. So the camera image can displaced in here, and about the results you can view in this area. And this is the status. The camera status you can view this area. And this is the overview. So overview means it can provide an overview of this flow. Okay, so if you want to create a new flow, you can drag the tool to the process editing area to create a new flow, and then to double click the module, you can set the parameters in like this page. Okay, and next I will introduce the important parts of the vision kit operations. So it's calibration. So the calibration is used to determine the conversion relations between the camera coordinate system and the robot arm coordinate system. So we can know the endpoint, and then is the endpoint the calibration. So endpoint the calibration means the conversion between the camera coordinate system, and then we can use the calibration tools to make the calibration files. So for the operations, the first we need to collect the magician to the computer via the USB cable, and collect the camera to the computer via the USB cable, and to plug the dongle into the computer, and then to open the general solution. So when they enter this general solution, we can to create a new flow like in this image. So in order to get the calibration file, we need to create this flow as an image source and the calibration board and the endpoint, the calibration. So before start the setting a new flow, we need to set the camera parameters. So we can set the camera parameters to by click this camera icon, and to set the pixel format to the mono 8, then to adjust the pictures and exposure time and light to adjust the camera bright list. So even if it's not bright enough, you can set the trigger source to the software in the trigger settings in this one, or in this one, to set this in the software. Okay, and then to click the image source, so we can enter this page. So in this page, to set the related camera to the global camera. So in this global camera is set by the last time. And then to click the play icon in this toolbar, so you can get an image in the image area. So and then on the basic of the parameters, we need to set the input, the source to the input, the source image date, and then on the run parameters area and as the calibration board type. In this area, we need to set it to check board calibration boards, and then to check the confirm. So another parameters is set it by default, so it's don't need to be modified. Okay, and this is the endpoint calibrations. And actually, as for the endpoint calibration, here are 4 points the calibrations and the 9-point calibration. But and the 9-point calibration has a higher patience. So in today's lesson, I will introduce how to do the 9-point calibration method. So at the first, we need to set the calibration, the points, acquisitions to the trigger, the activations, and then to set the translation number to 9, and then to click the camera icon to get the image and show in the picture like this one. So the calibration 9 points in the orders of the green arrow, so like this one. So we need to get the point from this, from the 0 to the 8 in this order. Okay, so and then to click the robot arm icon on the toolbars to open the Dupe Studio, and to choose the magician and to click collect. So set the pen at the end effector of the magician. So you can move the robot move by clicking the X or Y axis. And next, to jog the X-Y axis on the Dual Studio to make the pen move to the 9 points in the orders of the green, the arrow, and then to write down the point value in each ID. So there are 9 IDs from the ID 0 to the ID 8. And then to click the locations icon to get the code. To get the current XY coordinate or to manually input the coordinate and then to click the confirm. Okay, and this is step 11. So in this, you just need to click the create calibration file to save the calibration file. So the calibration file will be used in the following demos. So please note the relative position between the camera and the magician can be changed. So otherwise, you must create the calibration file once again. Okay, next I will show you a Vision Kit demo. So in today's training demo, we are about to detect the corners of those blocks and to sort them. So to do these operations, we need to do in these 3 steps. So at first, we need to extract the corners in camera image and sort the corresponding blocks according to the corner, and then to get the calibration file to convert the image, the coordinate to the the coordinate according to the calibration file, and then to sort the corner blocks by the Dr. Magician. Okay, but because this part is most important and the difficult, so next we're about to show how to operate to do these demos. So I will share my screen about the real operation. Okay, now I shared my screen about the Vision Studio. Okay, so at the first, okay, we need to, okay, and first we need to enter the general solutions to create a new flow. But before that, we need to set the camera. So okay, I'm sorry. I will show it once again. Okay, so when we enter this page, we need to, at first we need to set the camera. So we need to set the camera to the U3VMV series camera, and then to set the trigger settings to the software. Okay, and then to click confirm, and then to create the new flow. First is the image source. So image source we need to set to a camera, and then the camera name is the global camera. Okay, and the next is the calibration board. So in this calibration board, we don't need to change the parameters. They are set by default. So next, to add the endpoint. So in endpoint calibration, we don't need some of the parameters. So needs to click this play. Okay, now we put a calibration the board on the work face of the magician. Okay, then to collect the magician to the Weixin Studio and collect it. Okay, and send the pen as an end effector. Okay, and then to home the magician. Okay, so we can get some of the images in the image source area. Okay, so now we're about to get the points, the 9 points. Okay, so we need to clear the calibration file and to create a new calibration, the new point. So we can click execute to get the new calibration, the image error. Okay, so we can make the magicians, the end effector, the pen to get the point of the error 1 of the 0. Okay. And to okay, and copy this the real physical the x coordinates and the y coordinates in the calibration points. And then to get the ID 1 point coordinate. So like in this way, we need to get the 9 points. So and then today I just show you an image about how to get the 9 points. So in this way, to get 9 points and then to click the confirm and then to create the calibration file. So the calibration file is finished. So on the next, we are about to create a new flow. So the first is needed to set the camera settings. So we need to set the cameras to choose the camera and then to set the pixel format to the RGB because we want to set the camera blocks and then to set the training settings as the software. Okay, then at first we need to add the image source to set the image source camera. Okay, and then to extract the color. Okay, so we need to set the colors, the RGB, the parameters. But we have the better way to get the counters, the RGB, the parameters. So we create another the flow to get the blocks, the RGB parameters. So by in this case, we will change the papers to the white papers to get a better effect. Okay, so we can know from the image source, we can know there is the blue, the blocks. So we need to choose its shape and cover this blue box. And click the confirm. Okay, so we can know in histories here are the RGB parameters. So for example, the pass 3 to 1, pass 3, pass 2, pass 3 it means channel 1, channel 2, channel 3. So channel 1 is R, channel 2 is G, yes, and the channel 3 is B. So in time we need to type the channel 1's the mini values and the max value in each channel, like this way. And to click the confirm. So we can get the same results in this color extraction. Okay, and next to add the image morphy, and in this we don't need to set any parameters. Okay, and this is the block the exercise. So instead we need to set the threshold mode is the no resolution, and the polarity is brighter than background, and then to click the confirm. Okay, this is to create a calibration the transformation to transfer the image coordinate to the basic coordinate system. So each time we need to choose the calibration file and create before by Vivation Studio, and then to click the confirm. Okay, to click the play, we can get the image of this block. So if we change the collection, the camera can extract the blocks as well. Okay, next to add the move point and the suction cup in the move point and the suction cup. So in move points, we need to set the XY coordinates is the output point, the transport X, Y, and output the transport Y. And in venue we can do set by manually to set the venue that we want to the robot move the height. So we set the value is minus 43 millimeters. And R is 0. And this is to set the move mode. So we set it to jump. And to turn on the run parameter. Okay, and to set the move point the coordinate. And then we're about to install the suction cup on the robot arm. Okay, and okay, next we install the suction cup to the end of the forearm of merge shape. So because we want to the robot move to this point, so we need to write this point coordinates in the move points. So why Z means the height of the robot jumps. So we set the height is minus 41 meters. And then to turn off the. Okay, we can run the program. Okay, so when you change the move mode to the jump, so that's the move L or the move G. So after we changing the move mode, we can try the once again. Okay, so we can see the remote move to extract the blue blocks and move the blocks to another position in the jump motion. Okay, thank you for your watching. So for this Wishing Kate, if you have any questions, you can talk with us. Or type the questions in the Zoom chat box. Hello, okay, so next I will to share with you some of the frequently asked questions. So number one question, the dongle has been plugged into the computer. So why does it open the Weixin with the software personalization not active? So in this case, the dongle IMVSVM6000 just only supports Vision Studio, the version 1.4.2 and below. So it doesn't work on the V 4.12. So the version 4.1.2 is the new version of the Vision Studio. So this time, this dongle can't support the Vision Studio, the old version, just supports the new version and software. So you can get the version information from stickers. And number two questions. Why can't open the seed file? The error message is failed to load solution. So in this case, the fails to load is a problem with the field storage path. So the software doesn't support shared path or mapped math. So you can put the file on the local disk from the another path. So, and the next question is why can't collect the camera and the error message is no right to access device. So in this case, because the U-port camera left review is not support, so it doesn't affect the use. Okay. Okay, so about contents is about the Vision Studio and the Vision Kit. So if you have any questions, you can talk with us, or you have the another questions about another part, or for example, the 3D printing or the laser engraving or another part, you can talk with us. Okay, I'm very glad to hear some questions from you. And about today's training session, I will appreciate if you can give us a suggestion or the evaluations. It can help us to improve our the training sessions in the future. Okay, and I want to know if you haven't finished the anket. I hope you can take a few minutes to finishing this anket. I will appreciate, or you can talk another questions about the dual mergings applications with us. And I will close this the meetings in the 5 minutes. 私聊你了。我的麦